Okay, question 26. So the question says the diagram shows a logo made from 3 circles, and you can see we've got 1 circle here, another one there, and another one there. So it says each circle has a center 0 or origin, and then Daisy says that exactly 1/3 of the logo is shaded. So you can see that this is shaded. Is Daisy correct? You must show all you're working out. Right, so at first instance, we can perhaps say that maybe Daisy thought that since there are 3 circles and this part was shaded 1 out of 3. But let's see if she's correct on this. So to start off, the first thing that we're going to need to think about is how we're going to prove whether Daisy is correct or not. So to figure out whether the shaded circle is exactly 1/3 of the logo, we think about the area, and we know that the formula for the area is pi r squared, right? And we're going to be working in terms of pi for this to make it a little bit easier to avoid rounding up and rounding down errors. So let's then start assigning labels to our circles. That's the best way so that we can keep track of what we're doing. So I'm going to say this from in to out. So that's C1, that's C2, and I'm going to call this C3. So let's start off by calculating the area for circle 1. I'm going to use a different color. So circle 1 has a radius of 4. This is all in centimeters, but I'll just avoid the measurements for now. So area equals, so pi 4 squared, so that equals pi 16. And then come on to circle 2. So circle 2 has a radius of, well, 4 plus 3 gives us 7. So we know that the area is going to be pi 7 squared, which is pi 49. And then finally, for the last one, we say C3, so it has a radius of 10, so 4 plus 3 plus 3, that's 10. And so we say the area equals pi 10 squared, which is pi over 100, right? So now what we want to do is, we know that the shaded area is going to be equal to just this part here. So that's the area of C2, entire area of C2, subtracted by the entire area of C1, because then that will just give us that shaded region there. So we know that we had from C2, we had 49 pi. So we're just going to flip the way that we write it by having the numerical value first. Minus 16 pi, so this is the shaded area, okay, equals, and then so we're going to get 33 pi. So we know that the total area, equals 100 pi, right? But the shaded area equals 33 pi. So let's do this, 33 over 100. So we ask ourselves, is this cancelled? Yep. And then we have 33%, which is 33 over 100. So is this a third? Well, not exactly, because a third is 33.3 recurring, which would be categorized as a third, although it's close, but we say, but Daisy is Daisy. Daisy is wrong. Sorry, Daisy. Close, but she's not exactly there. Right, 27. So it says the table shows information about the weekly earnings of 20 people who work in a shop. So when you get towards the last set of questions, which are arguably harder, one of the things that's good to do is kind of just highlight some of the important elements that you really need to consider. So we'll just highlight 20 people. So it says these are the weekly earnings in pounds, and this is the frequency. So this means this is how many people earn this weekly earning, okay, in pounds. So this is work out the estimate for the mean of the weekly earnings. So we know that the estimate is essentially summation, or the sum of x divided by n. N is the number of terms or the frequency that's here. Now, it would have been easy for us to simply use this formula if we had a discrete number, but here you can see we have an interval. So how do we figure out questions that have this interval? Well, in this situation, so when discrete number, but since that's not discrete, we use the midpoint to figure out our x for each one. So for here we got 150, 250. So we can, one thing you can do is you can say I'm just going to call it XA plus XB, okay, just those two, and then divided by 2, which will give us the, just going to put X midpoint, okay. This is my own notation just for you to understand the concept, but essentially it's a simple case of adding this, adding that, and then dividing them. So 150 plus 250, so that's 400, and then divided by 2. So 400 divided by 2 is 200. I mean, you can just read off there and see where the midpoint is without doing it. So let's do that. 300. Obviously, if the numbers were much larger and they weren't so easy and they were further away from one another, then you could perhaps use this formula to calculate it. So 400, 500, and then 600. Okay, let's use a different color now. So the next thing we'd want to do, so we need to multiply by the frequency. So here we have 1, so times by 1, times by 11, times by 5, multiply by 0, multiply by 3. So let's get our answers. So this is going to give us 200. So this is 3,300. This is 2,000. And this is 0. This is 1,800. So if we add all of these up, so just the smallest, so the largest number first, 2,000, and then 1,800. And then 200, just use simple addition, 0, we have 0 here, and then here we'd get 3 and 7, so we've got 7,300. And then, well, what's the frequency that we have? So 1 plus 11 gives us 12, so let's do that. So 12, 17, 17, and 20. So we have a frequency of 20. Write that out a little bit more neatly. So they all add up cumulatively to 20. So we come back here, divide by 20, cancel the 0. We get 730 divided by 2, which gives us 365 days. So the answer would be £365. Why did I say days? £365. So Nadia says the mean cannot be the best average to use to represent the information. So do you agree with Nadia? You must justify your answer. So in this particular case, if we think about it from a statistical perspective, well, yes, Nadia does have a point. And the reason for that is, in the instances where you have 3 people earning a lot of money, then the mean will be skewed, because you are talking about, say for instance, a small proportion of people who earn a lot of money, which means that when you calculate the mean, it will be distorted, it will be skewed towards the heavier side, which in this case will be the higher earners. So I would say yes, Nadia is correct, that it's not representative, and perhaps the median may be better, and that's because median not affected by the extreme values. Okay. So question 28. So it says here is a rectangle, and you can see it's got width y, length 5x minus 9 on this side and 2x plus 6 on this side. And so all the measurements are in centimeters, and the area of the rectangle is 48 centimeters. So it says show that y equals 3. Alright, so that's not an issue. So the first things first is, well, we know if this is y, then this is going to be y as well. And we know that the area of a rectangle is going to be length times width. So we know that 2x plus 6 equals 5x minus 9. So let's try and group together our like terms so we can find our x. So I'm going to take my x variables there, I'm going to take my numerical values to that side. So we get 5x minus 2x, and then, rather I should put it written it the other way around. So we know that this is going to become negative, this is going to become positive. So we'll get 6 plus 9, and then 5x minus 2x. So here we'll get 15 equals 3x. So that tells us x is going to be equal to 5. So now we can sub that 5 back into our value here. So let's use a different color. So 2, and then we'll say 5 plus 6. So 2 times 5 is 10, plus 6 is 16. So we know that this entire thing here is going to be equal to 16. And we can do the same thing for 5 minus 9. So that's 25 minus 9 gives us 16. So the same thing, we're just double checking here to demonstrate that our answers are correct. So centimeters. Right, so we know based on this here that our answer is going to be 16 times by y, written as 16y. Well, we know it equals 48, so that means that implies that 48 divided by 16 equals y, which equals 3. So we wanted to show that it's equal to 3. We've shown that it's equal to 3, and therefore we've proved it. Question 29. So it says Brogan needs to draw the graph of y equals x squared plus 1. So it says write down one thing that is wrong with Brogan's graph. Well, instinctively, the first thing you notice is that the graph is not very smooth. Doesn't have any curves. It's actually joint up, line to dot. So the first thing that I would say, which I've noticed, is Brogan should have drawn a curve, because this is not a curve, so it should have been a bit more smooth in his graph. Okay. So question 30, which is the last question. So it says, in a sale, the normal price of a book is reduced by 30%. The sale price of the book is £2.30. So again, I'm just going to highlight something that you can do. So reduced by 30. So the sale price of the book, so book now is £2.80. Okay. So it says work out the normal price of the book. So we know that the book, the normal price was 100%, and the sale price, so sale price, well, it's now been reduced by 30, so it's going to be 70%, and we know that the sale price is £2.80. So what we can do is we can find 10%. So let's find 10% and then multiply by 10 to give us 100%. So we know that £2.80 is 70%. So what we can do is we say £2.80. So I'm gonna divide by 7, divide by 7. So here we get 10%, and here we get 0.40, so 40 pence if you think about it in pounds. And then we want to multiply this by 10, which gives us 100%. I'll write that out a bit neater. Okay. And then here we'd get £4. Put 0, 0, but £4 essentially. So the answer is £4. The normal price of the book is £4.